Alright, students, so we're moving along. We're getting to the stuff that you really need to start to pay attention to, going into the cardiovascular system. These are where things go wrong. We go into the heart, you're really going to have to pay attention there because a good portion of the population has hypertension. So right now we're going to start talking about the blood and the parts that make up the blood. So we'll just jump right into this. We're talking about cardiovascular system, chapter 20, starting off with the blood. Okay. The main thing about the cardiovascular system is it's a transportation network. I want you to think about blood as primarily water, so basically it's like a river system. And we have all the red blood cells, white blood cells, everything is traveling along that river and is transporting everything around throughout our entire body, dropping off nutrients, picking up waste. Okay, so we have lots of nutrients. We get oxygen from the lungs. Let me see, I always like to do the drawing. Okay, oxygen from the lungs. Carbon dioxide, which is a waste product from making ATP. All of our enzymes and hormones, they're going to be transferred in the blood to go to the organs, whatever tissues need it. Ions are really important because they're the ones, they are our electrolytes that are responsible for doing the muscle contractions, creating charges in our body. Metabolic waste is going to be all of our uric acids and all of our ammonia, our byproducts from just chemical reactions in our body. Has to go to our kidneys. Well, you need to remember, our liver, what that does is our liver it makes things so that it can be transported in the blood. Our liver is the detoxifying area. Our kidneys are the removal. So our kidneys get rid of stuff, take it out of the body. Our liver makes it be transported through the body. And leukocytes, stuff like that, are all of our white blood cells. Everything in our immune system has to go through our blood to get to throughout the whole body. Other things, stabilizes body temperature, the heartbeat and everything, increases body temperature, movement of the blood actually creates heat. Blood loss, fluid buildup, that's going to be our clotting process, and pH, electrolyte imbalances. So we'll go into all that stuff. Okay, the components of the blood. So plasma, that is going to be the liquid. Formed elements are everything that was formed in the bone marrow. So what's formed in the bone marrow is going to be our red blood cells, white blood cells, and our platelets. Okay, just remember, those are the three things that are formed elements. Plasma is going to be made up of everything else. There's a lot of else. So we'll start off with just dealing with our plasma. Now realize plasma makes up 46 to 63% of our blood, depending on if we're dehydrated or not. The components of plasma. If you take a look, the main things I want you to be aware of. So, don't worry too much about the organic and inorganic, all that stuff. That's just going to be like bicarbonate and things like that. The only thing I want you to really be aware of with our plasma is we have our albumins. So our albumins, they are proteins, and they are responsible for making it so that our blood vessels are going to allow fluid to go out of the blood vessels or bring fluid back into it, which is the movement of water is osmosis. So the amount of proteins we have dictates where the water is going to flow. So let's keep it simple like that. So that is our albumins. Our globulins are going to be, best way for me to understand it is, globs are like a protein, but on that glob of protein we're going to have hormones, fats, other things attached to it, immune cells, so our immunoglobulins, our antibodies, things like that. So globules are a glob. Fibrinogen is just going to be responsible for helping with clotting factors, to help to form a scab and help to lay down the matrix for which we can then start to repair. And other solutes are just going to be, our electrolytes in there, just other things, our trace minerals, some of our vitamins, just things that are responsible for life. Okay, now whole blood is everything. When you put it in a centrifuge, then what you do is you spin it around, and the heavier stuff goes to the bottom. Okay, then everything gets layered according to how heavy it is. So the first thing we're going to have is going to be, so our whole blood is going to be everything. It is our plasma, our packed cells, and our platelets. So whole blood combines everything. When we spin it out, our red blood cells, so that's going to be our erythrocytes. Okay. Erythrocytes means red blood cells. Cytes are cells. Erythema means red. Okay. Leuko means white. So white blood cells, red blood cells. The main part of our packed cells, which is going to be our formed elements, is going to be our erythrocytes. We'll get back to this picture in a little bit. Okay, so whole blood, 4 to 6 for men, 4 to 5 for women. When you start thinking about it, you give up a pint of blood when you donate blood. This is the reason why they want to know how much you weigh. If you're not big enough, you can't give blood because it would take too much blood out. You go into hypovolemic, low blood volumes. Normal is nice, means normal. Hypervolemic means that you have too much volume, so too much liquid in your blood, which also leads to high blood pressure. Okay. pH, we've already talked about that, 7.35, 7.45. It needs to stay within that range so chemical reactions can happen. Okay, so plasma makes up a little over half of the volume of the whole blood. The majority of plasma is going to be water. And then we're going to have a little bit of proteins, globulins, fibrinogens, and 1% of the electrolytes, organic nutrients, some waste products. Okay, so our plasma, as you can see right here, all the yellow, that is our plasma. Right down here, we're going to have a little other layer. That's going to be our leukocytes. This is our erythrocytes. Erythrocytes, they have iron in them, which means they have more weight. So when you spin it out, they're going to float to the bottom. Our white blood cells are not just water. They have some granules in them. So what they have is they have a little bit of weight to it, but not as heavy as an erythrocyte. Plasma is pretty much just liquid. Okay, and we already talked about all this stuff in here. Everything over here we already talked about. Okay. The difference between plasma and interstitial fluid. Interstitial fluid is, so you remember we have a cell. We have a cell right here. You have the desmosome zones that connect them. But the little spaces in between here, that's your interstitial space. That space is filled with fluid. Now, that fluid right there is going to be what can be put out of a cell or taken into a cell. And it is our blood vessels that actually add to that interstitial fluid. So we'll go to the blood vessels in a little bit. Okay. So the difference between plasma, which is inside of our blood vessels, and interstitial fluid, which is outside of our blood vessels, outside of our cells. Dissolved oxygen concentrations. Okay. Let me see. All I want you to understand is oxygen is in our blood, so it diffuses from our blood into the interstitial and into the cells. Okay. That's the main thing you need to understand there. Carbon dioxide is low in our plasma, so therefore it goes from our cells, because carbon dioxide is a waste product for making ATP, goes from our cells, interstitial, into our plasma, which is actually just going to be our blood, really. I don't want to get too carried away with this plasma stuff. Okay, we talked about albumins, globulins, fibrinogen. We're going into a little more detail now. So, our albumins, what they do mainly is osmotic pressure. They just control where water is going to go. They do transfer some fatty acids, thyroid hormone, some other steroid hormones, because albumins hold on to fat. Okay, our steroids are cholesterol-based, which is fat. Globulins, which is going to be our immunoglobulins, are antibodies. Okay, so they're going to attack pathogens, foreign invaders. Okay. We do have some transfer globulins, and all they do is they hold on to an ion with like a small charge to drop it off, and a couple of other hormones that aren't fat-based, the ones that are amino acid-based, which are like protein-based. Okay, now plasma proteins, so getting down to this, fibrinogen. Okay, fibrinogen is the largest plasma protein, and what it does is it helps with clotting process. And then what it does is gets fibrin, forms the clot, and actually starts to get some healing going on. Okay? So let's understand, fibrinogen, it helps with, make sure you don't bleed. Now we go to our formed elements. Formed elements are everything that's made in the bone marrow. So that's going to be our erythrocytes, our red blood cells, leukocytes, white blood cells, and our platelets. Platelets help to initiate the clotting cascade, and they're the first ones that start to form and prevent the blood from flowing out. Now we'll start talking about just red blood cells. So hematocrit, what we're talking about there is how much red blood cell is in a volume of cells. Okay, so it is the packed cell volume. So we have a volume, a certain number, right? So we have, 5 milliliters. How much of that 5 milliliters is actually going to be red blood cells? So that is going to be our hematocrit. Okay, so packed cellular volume. Okay, also called the volume of packed red cells. Just means you have this much whole blood, how much of that is going to be red blood cells. Let's not get carried away here. Okay, red blood cells, very small. Okay, see, we have in a millimeter 5.4 million cubic, just million cells per cubic milliliter. So we have massive amounts of red blood cells in our body. Okay, that's for males. 4.8 million per cubic milliliter for a female. Milliliter is really tiny, so we have a little space like that, and it's like 4.8 million red blood cells in there. So they're tiny. They measure about 7.7 microns diameter. Now they are this disc, and they're biconcave, which means they're missing a circle in the middle. So thin central region, which is that biconcave, no organelles, no nucleus. They contain hemoglobin. Hemoglobin is a combination of iron that's carrying oxygen. Iron oxidizes. Iron attracts oxygen, which is why we have to have iron in our red blood cells, because it attracts oxygen from our lungs so it can go through our body. So here you go, little biconcave disc. 7.2, 8.4 micrometers, so really tiny. Now, without having a nucleus, it means that it doesn't really have the ability to think or stay alive, which means it's only viable for about 120 days. You remove all the organelles, so all we have now is a whole bunch of hemoglobin in there. So it has one purpose: carry oxygen. We replace about 1% of our circulating red blood cells every day. Okay. The coolest thing about our red blood cells that I think is it doesn't have a mitochondria. So by removing the mitochondria, and the mitochondria is where we actually take oxygen, we mix it with glucose, and we make ATP. Take out the mitochondria means we're not going to burn oxygen. So I want you to think about a red blood cell as it's just a delivery truck. Okay? In the back of the truck, it's just a box. All it does is carry stuff. All the red blood cells do is carry oxygen. Nothing else. So don't get carried away with it. Red blood cells are simple. Extremely important, but simple. Okay. Now, the relationship between red blood cells and hemoglobin. Red blood cells carry the hemoglobin, and the hemoglobin attracts oxygen. That's all you need to understand about that. 95% of a red blood cell protein is hemoglobin. So their purpose is to carry oxygen. They do it very well. That's about all you need to understand there. Now, what we're going to have, so iron, the periodic table, iron is Fe2. So we have our heme, and a globin is just a protein. So that protein is going to be made up of 2 alpha chains, 2 beta chains. Best way to do it is a picture. So this is an alpha chain, this is a beta chain, alpha chain. Now, in order to get this to work right, we need to get the genetics from mom and dad in order to have the alpha chains and beta chains made just right. There's a condition called thalassemia where we don't make a chain. If we don't make a chain, we can't carry as much hemoglobin, so we can't carry as much oxygen per red blood cell. That's a problem. There's where we get to where we can't make either chain. It's called hydrops fetalis, and the baby won't even be born alive. So as we go through here, what we're doing now is, as you can see, for every protein, so every chain with the hemoglobin in it, we have some iron. That iron now is going to attract oxygen. So one heme, it has 4 chains. Each chain can hold a hemoglobin. So there's 4 hemoglobins. There's 4 irons per hemoglobin. Adds up to a large amount of oxygen carrying capacity. Now, they get a little carried away on this one. I don't like the way the book's doing this. we're talking about blood typing. Now, what you have to understand is blood typing is really simple. We have a red blood cell. There, I'm using red. Now, on the surface of it, we will have an antigen. So let's say this protein that's sticking up right here, we'll say this is an A protein. Okay? Antigen A. This weird green. So this right here is going to be a B protein. And some people will do this phlegm orange. Some people will have, the D protein is actually the RH factor. Okay? So RH, if it's RH positive, it means they have that protein. If it's RH negative, it means they don't have that protein. That's simple. If their blood type is A, it means they have the A protein. Okay? If it's B, it means they have the B protein. If it's AB, it means it has both the A and the B. If it is AB positive, it means it has the A, the B, and the RH. Okay, now, why are these proteins? These proteins are known as antigens. Antigens are very important when it comes to the immune cells because we recognize the proteins on a cell wall. So our immune system recognizes that. And some of those proteins, if they're foreign, our immune system, what it does is it actually makes antibodies that attach onto this antigen. Okay? Now, if you get the wrong blood type, you're going to get the wrong, the blood that you get will not have the right antibodies on it. Not antibodies, but the right antigens, which means it's going to attract antibodies. When the antibodies come, some antibodies come, what they do is they link the blood cells together to form a clump. Okay? So that is agglutination. So agglutination means they glue them together to make a big ball. Therefore, a white blood cell, a macrophage, could come around and phagocytose it and kill it. So, that's all you need to understand. This is our blood typing. Our blood typing, the positive means you have RH. If it doesn't say, it's just like, you have type O negative, it means, O means you don't have A, you don't have B. O negative means you have no A, no B, no RH. Okay. Things get a little hairy when we start talking about this. That RH kind of throws it off. Now, let me see. Let's move on with this, and we'll come back to this guy too. Now, talking about the blood types. People who have type A blood, they have the A agglutination. People with B have the B. Now, A means they have the blue agglutinine. Now, the notion means that it is on the red blood cells. The ine means we don't want it in there, so that means it is an antibody on the plasma. Okay? Don't get carried away with this. Let me put it like this, okay? If you are a type A and you get a type B blood, the blood that B marker on the blood, it is now going to attract. So here is that B protein. So if you're type A and you get B, you're going to have B agglutinins in your plasma, and what they're going to do is they're going to come running around here. We'll make it in one of these colors. I've never used this one before. They'll come running around here, and what they're going to do is they're going to attach on here, and then they're going to grab the other cell that has the B, because you don't just get one blood cell, you get a mass. They're going to attach to that, and they're going to glue it together. Okay. Let's see. So, RH, all that. So, here's the way it works out. So, these surface antigens right here, these are what they're talking about. That's how we recognize something as being foreign. So, these little surface antigens. So, type A, you have the A antigen. Type B, you have the B antigen. If you're type AB, you have the A and the B. If you are O, you got nothing. It's a perfect circle. Now, these are antibodies that will attach on here if you get the wrong blood type. Now, think about this. If you were to get AB positive, that means you have the A antigen, the B antigen, and the RH. So you have all those antigens. It means that your blood, you can almost take, so you are the universal recipient. So you can get anybody's blood because your body doesn't recognize anybody's blood as being foreign. But if you are a type O negative, it means that you have this nice, clean cell outside. So your body now is making sure nothing else gets in that's not clean like that. So what happens now is anything that has an A, a B, or an RH is going to be looked at as foreign, and your body's going to attack it. Okay, but if you give type O, there's nothing on here for any antibodies to recognize. So type O negative, universal donor. Type AB positive, universal recipient. Okay. That's pretty much all you need to know. We'll go into more detail on that later on. Let's see. Same thing. This is a big topic, so I don't want to waste time on this. Okay. Too much blood typing. Okay. Let me just tell you what happens now. So when everything gets clumped together, it destroys it. Let's talk about white blood cells. White blood cells are cool. They're called leukocytes. We have 5 major types of leukocytes. Some of them are granulocytes, some are agranulocytes. All that means is we have these little grainy looking things, looks like sand. There are little protein packets in there that carry, some enzymes and stuff like that. So, neutrophils. Let me just go into here. Let's see, where's the one that I wrote on? Okay, so we have our neutrophils, eosinophils, basophils, monocytes, lymphocytes. All right. Which ones are the granulocytes? Come back over here. Neutrophils, eosinophils, and basophils. What do they look like? Neutrophils, eosinophils, and basophils. It just means that around this area you can actually see more like substance. That's all. You see these little circles. Granulocyte. You don't have these little circles in these. Okay. Now, we don't have a lot of white blood cells unless we have an infection. Okay, white blood cells, short lifespan. They can actually chase, they can track, they can run after pathogen, something that's invading the body. They do it by something called chemotaxis. Taxis means movement, like a taxi cab, planes taxi down a runway. Their movement is towards a chemical. So the body releases a chemical saying this thing is dangerous, and this white blood cell swim after it and get it. They can squeeze between the endothelial cells in our capillaries, so they can be pliable. Let's move on through. Okay, neutrophils are our most abundant white blood cell. Now, neutrophils, what I need you to understand about those are they're tough, but they're not the toughest guys in there. Okay, so neutrophils are the first to fight. So you get an owie, you get a booby, you get a scratch, something like that. Neutrophils rush in there because they just like a fight. They're the first to try to protect. Okay. And they can do some phagocytosis and have enzymes and stuff like that. Eosinophils, they show up when there's an allergy or a parasite. Okay, so they help to mediate an allergy or attack any kind of parasites. Our basophils, when there's an allergy, they release histamine, which causes all the mucous membranes to get inflamed and the runny nose, watery eyes, and all that. They also secrete heparin. Heparin is an anticoagulant of blood, so it's a blood thinner. Okay, monocytes, they can become macrophages. So when a monocyte is within the blood, it's a monocyte. When it leaves the blood, it becomes a macrophage. Now, macrophages are tough guys. They just cruise around, and they're huge. They can engulf almost anything and destroy it. When there's an owie, so you get a cut, the monocytes now actually flatten out and become like an octopus that lays over on top of it like a patch. And anything that comes around, they can destroy it and hold up that antigen to tell other white blood cells, hey, we're being attacked by something that has this mark on it. Okay, you see eosinophils, let me see, parasites, and talked about that one. Basophils, histamine, and heparin. Let's see, moving along pretty good here. Okay, now what we're going to have here is we're going to have our T cells, B cells, and our natural killer cells. These are our main immune cells. Okay, so these are lymphocytes. So lymphocytes mean that they're going to go to our lymphatic tissues. We'll talk about that in a little bit. But we have our T cells. T cells, they attack foreign things directly. They're like hand to hand. Our B cells, what they do are they make antibodies. they do like drive-by shootings, okay? Our natural killer ones, they just kind of cruise around. They see cancer or something's not working right, they just attack and kill. Platelets, all you need to know about them are they actually form the blood clots. So when a platelet comes out, you get this from the white bloods. When a platelet comes out from the bone marrow, it's in this big cell called a megakaryocyte, and then it breaks free, and we have all these little platelets that come out, really small. Platelets are responsible to signal healing effects. So therefore, we are now doing what? Platelet-rich plasma, where you spin out the blood, you pull out the individual's platelets, and you inject that into like a ruptured tendon or something, and it increases the healing, it speeds it up. That's like a new treatment they're doing. Now, platelets used to be called thrombocytes. Thrombus is a blood clot. So if you don't have enough platelets, you have so a thrombocyte, a cell that forms a thrombus, a blood clot. Penia means not enough. Okay? Higher than normal, osis means a condition of. So you have a condition of thrombocytes. Too many platelets. Okay, platelet function. Clotting blood clot keeps you from bleeding. That's all. Let's not get carried away with this. Hematopoiesis is the production of making these cells. Okay, so hematopoiesis is blood formation. Hematopoietic stem cells are the stem cells that can differentiate and become different other cells. Okay, so hematopoiesis, we're going to have, it will make erythrocytes, platelets, basophils, eosinophils, neutrophils, monocytes. Those are all of our cells. Those are all of our formed elements in our blood. Okay? Now, myeloid just means it's all made in the bone. It's all made in the bone marrow. But when we start talking about leuko is made in the bone marrow, but lymphatic, it is made in the bone marrow, but it goes to mature somewhere else in the thymus. Okay, so lymphopoiesis. So we are now going to have our lymphocytes, our B lymphocytes, T lymphocytes, and our natural killer. All made in the bone marrow, but T lymphocytes go and they mature in the thymus. They differentiate. So here it is. Here's our hematopoietic. Pluripoietic means it can become, this cell can become any of these guys. That's all I need you to understand. Keep it simple. The myeloid and the lymphoid only become important when we start talking about leukemias. Leukemia is a blood disorder where we have too many white blood cells. It can be a lymphoblastic or lymphocytic leukemia, which means it's a lymphocyte, or a myeloblastic or a myeloblast, which means it is a myeloid stem cell. That's all. If it's a lymphocyte one, it's going to be B cell, T cell. If it is the myeloid, it can be an eosinophil, basophil, all the cells. One thing they all have in common is they don't function as a regular white blood cell because it is a cancer. Okay, erythropoiesis is how we make red blood cells. So, once again, pluripotent stem cell, it goes through and we come out with a red blood cell. Hemopoiesis is how we're going to make a platelet. I don't go too crazy with this stuff. It's all right here in the chart. Okay. Let me see, differentiation. Hey, we took care of this. This actually wasn't too bad. Hopefully this wasn't too confusing. Just think about it though. All our blood does is red blood cells carry oxygen, white blood cells protect us, platelets keep us from bleeding out. Plasma is going to have all of our blood proteins in it. So just keep it simple like that. Blood proteins are albumin, immunoglobulins, so globulins. And then we're going to also have in our plasma some of our formed elements, not formed elements, but some of our vitamins, minerals, things like that, trace minerals, elements to stay alive.